So yeah, welcome everybody. Thanks for having me. This is an awesome location. So following the previous talks and panels about activism and the launch of the ACT DAO, now comes a completely uncontroversial topic, Lightning, given by a Blockstream engineer. So my name is Christian Decker. I started with Bitcoin in 2009, reading this obscure paper. Later, I did my PhD on it, and since a year, I now work on Blockstream, working on the same scalability issues that I started my PhD with. And I think now we actually have a solution. So before I begin, if there are questions, please interrupt me. The worst thing that can happen is that I tell you it's on the next slide. I really enjoy having interactive discussions, so feel free to interrupt me at any time. So the title of my talk is buying coffee at lightning speed. And that's going to be the topic for the whole discussion. So I'm a software engineer. I like my coffees. I've often been called a coffee compiler. And being a Bitcoin user, I'd like to use my Bitcoins to buy my coffee, right? So on the left-hand side, we have me. On the right-hand side, we have my coffee. How do I get to that coffee? So let's recapitulate what we would do in Bitcoin, in classical on-chain Bitcoin payments. So we'd create a transaction. This is a costly coffee, by the way. It's going to cost me 1 Bitcoin. This transaction takes 5 of my coins, transfers them 1 coin to the barista and 4 coins back to me, which is called a change. Simple enough. So I create this transaction, and now I send this into the Bitcoin network. Each Bitcoin node, when it receives the transaction, will locally verify that I actually have the money, that it is actually me authorizing this payment, and will update its local state to reflect that we now have transferred this money. And once it has done that, it will forward this payment to the next node until everybody in the network knows about this. This is simple Bitcoin mechanics. Almost all blockchains work like this, and this is what we call an on-chain payment. Maybe just one question. How many of you know how Bitcoin internals work? I see a few hands. You might get bored. Those of you who don't know how Bitcoin works might be challenging. Okay, so now the entire network knows about this transaction, but but the barista can't give us the coffee just yet. Why? Because, well, I could take those same funds and just spend them back to myself in what is called a double spend attack. After all, I had 5 Bitcoins, I transferred them, but if part of the network doesn't know about this transfer, then they would accept another transaction, right? So what we do is we basically wait. We wait for an expectation 10 minutes until some miner in the network finds a block. This block will include our transaction and thus confirm the transaction. I will display all of my transactions with the schema on the left. Dots on the left side are inputs, dots on the right side are outputs, and the locket basically means that this is confirmed. Okay, so this whole process took a few seconds plus 10 minutes in expectation in confirmation times. So by the time I get my coffee, it's cold. And I'm not a happy camper if I get cold coffee. and it's expensive, yeah, that's definitely true. So what is the main issue we try to tackle with Lightning? The main issue is that the blockchain simply does not scale. A few simple numbers. If every year we buy a 1 terabyte disk, every single one of these 7,500 nodes buys a terabyte disk every year, we'd be limited to 500 transactions a second. Simply verifying a transaction currently takes about 5 milliseconds. So that limits us to 200 transactions a second. The network bandwidth, assuming that we have a 10 megabit broadband connection, we are limited to 100 transactions. And yes, there is this artificial 1 megabyte limit that was imposed some time ago and that we are all discussing about. But trust me, that's the smallest of our problems. Eventually, we will bump up against the natural limits of our network. So what you see on the bottom is basically what the total throughput of the network is, measured by block propagation speeds in the network itself. So the bigger the blocks get, the longer it takes for the whole network to learn about blocks and hence learn about confirmations in the transactions. And the longer it takes, the more the higher the chances are for blockchain forks. Just a tiny tidbit for those of you who knew about Bitcoin and were getting bored. Okay, so how do we propose to solve this? We solve this by using micropayment channels or moving most of the transactions off-chain, not confirming them anymore on the blockchain itself. And the idea is a pretty old one. The idea came up in 2012, I think, by Jeremy Spielman. And the idea is basically, hey, how would it be if we were to create a persistent relationship between two endpoints and just transfer between us? After all, it's just us two involved in this, in buying coffee, right? Why does the rest of the network have to learn about this in the first place? So what we do is basically, I am green again, and I create a transaction that sends these 5 Bitcoins to a shared account between me and the barista. Okay, this shared account, which I'll denote with the bicolored dots, basically means that in order for transfers to be authorized from this shared account, both parties need to sign off on it. So any transaction spending these 5 Bitcoins will need both the barista signature as well as my signature. So we cannot unilaterally move them anymore. And now we can build on top of that. Now we can say, okay, our initial state is I will spend these coins back to me. All of these transactions so far are not on the blockchain. We are just setting up stuff. Okay, so once I have this situation, not much happened, right? We didn't move any coins. They ended up at my place again, so what's the use? We can, so I can actually add my signature to this, making this only half valid. The second signature, the blue signature by the barista, is still missing, right? But I give this transaction to the barista. Okay. Now I send my initial transaction, which creates the shared account. I send it to the blockchain, get it confirmed, actually creating the shared account. Now these funds are immovable, cannot be unilaterally spent, and I actually need to collaborate with the barista on how we decide to split them. Okay. Notice that the second transaction is not on the blockchain yet. The barista basically has taken it and put it in his back pocket. Now I come in on Monday morning, and I buy I want to buy my first coffee. So what do? I create a new transaction, spending the same coins, which are still there because, well, the barista didn't spend them. This time, I sent 4 Bitcoins to me and 1 Bitcoin to the barista, effectively paying 1 Bitcoin to the barista. I also sign it and give it to the barista. Now the barista has the ability to, at any point in time, add his signature, turn around, and put the transaction into the blockchain, effectively redeeming what was promised to him, right? He doesn't, though. He still keeps it in his back pocket until I come in on Tuesday, want to buy my second coffee, and I update this transaction again. This time I send two Bitcoins for the coffee on Monday and the coffee on Tuesday to the barista, and the change back to me. Okay, we actually do this a few times, and on Thursday I say, yeah, I'm not coming in on Friday. You can grab the money, and the barista will add his own signature, and now he will send it to the blockchain, confirming it, and actually getting the accumulated funds that we accumulated over time. So what did the blockchain see? It saw the first transaction, the setup transaction, and it saw the teardown transaction. And it does not see what happened in between. So this was the simple case where we basically just have 4 payments in between, but have 2 transactions on chain. We can actually do that many more times if we actually were to put 1 Bitcoin on there, which is now like $6.3 thousand. That buys loads of coffees, hopefully. And we could actually do this thousands of times, and the blockchain would only see 2 transactions. So this is the basic concept of a micropayment channel. Yes?
Yeah, so this is probably on the next slide, but how do you prevent a double spend until the coffee bar redeems your...
Yes. So I'll just repeat the question. How do I prevent a double spend until the barista closes the channel? So during the setup phase, I took some of my funds and put them into a shared account. That's done on chain. So once I lock those funds in, I can't move them anymore without the collaboration of the barista. And the barista wouldn't defraud himself, right? There was one question there?
How does it help if I want to have the coffee only once?
It does not. So the question was, how does it help me if I just want 1 coffee? In this case, it does not, because these channels are very limited, hence the name simple micropayment channels. We have more advanced systems where you actually can, so that's actually on the next slide, no, the second next slide, where you can actually extend the number of parties you can reach through a channel to anyone in the world. So whether you buy a coffee here and a donut there, you might do the payments using the same channel.
So the first time it always takes a long time?
The first time is the setup phase. That actually takes a long time, yes.
So I have to have a first cold coffee?
You could set it up ahead of time.
For a coffee, I mean, but not for a coffee, probably then.
Well, I mean, once we get to the Lightning Network, it will make more sense, because I can, since I don't have to know who I am going to pay later, I can actually create random channels ahead of time and then just do the payment through that. Okay.
If I spend the 5 Bitcoin in my account, is my 5 now locked?
You mean that one?
Yeah.
So this is an unspent transaction output. It is being destroyed by spending it. So every transaction basically takes inputs, deletes them. So it's like a pile of money. I take the pile of money, redistribute it. The original pile isn't there anymore.
Okay, so I cannot double spend it.
Exactly, yes. That's the whole point of having this first step on chain.
You also have a prepaid system there?
Sorry?
It's a kind of prepaid system.
It sort of is. Yeah.
You're assuming that people will basically collaborate. What if at some point they don't want to collaborate?
Well,
Money is locked somewhere and nobody can use it.
so there's, I didn't put it on the slides, but there's contingency plans for those as well. So the barista cannot be cheated out of his money. I, as the funder of the channel, could be, but there's check lock time verify, which allows you to, it's a bit more complicated.
Next lesson.
Next lesson, yeah. Okay, so what we basically are trying to do is we want to create a shared account, then we want to negotiate how we split up these funds once we close the channel, right? And we want to do this iteratively so that I can incrementally pay, or that I can get money back. And you notice that in this in the simple micropayment channel, I could not get money back because the barista was always the person that was enforcing the final state. So even if he refunded me some money, he would still have the transaction that gave him the maximum amount of money, and he would probably enforce that one. Okay, so how do we replace how do we update these channel states? We do that by replace by incentive, replace by time lock, and replace by threat. Oh, that's a typo, but anyway. So replace by incentive, the barista had no incentive to enforce an old state because he got less money. If he enforced a state where I only bought 2 coffees instead of 4, he would now get only 2 Bitcoins instead of 4. So why would he do that? Replace by time lock is a mechanism that I came up with during my PhD, which basically says, okay, there's this state, and the replacing state becomes valid before that one. And replace by threat is what Lightning uses. So let's see what Lightning does. So again, we have the setup phase where I, as the channel funder, take some of my coins, put them into a shared account. That's still the same. Now we have 2 areas of who knows what in this scenario. So on top is the barista state, on the bottom is my state. The barista and I both choose a secret. Now we perform the first payment, and the first payment basically is both of us have the mirror image transaction, but only I know so I know the transaction on the bottom, and the blue node knows the transaction on the top. So the 1 Bitcoin is his after a timeout of 100 blocks. Or it's the green ones if the green node knows the secret that blue generated, but it does not yet. And the opposite is true for the state of the green node. So it's the 4 Bitcoins are owned by the green node if the timeout elapses, or they belong to the blue node if blue can provide us with a secret. And what we do to invalidate now is we exchange secrets. So if I ever try to enforce an old state of that we agreed upon, then the other side can basically steal my funds. So let's say I want to enforce this. There is also supposed to be there. Okay. So once we have exchanged these secrets, I can no longer publish this transaction onto the network, simply because if I do so, then the barista can not only grab wait, it's the other way around. So if the barista publishes the upper state, then I, knowing this, the blue secret, can come along and not only grab the 4 Bitcoins that I actually own, but also his. So if the blue node misbehaves, yeah, sorry, it's flipped around. If the blue node misbehaves, then the green one can come in and punish him. I always like to make the comparison of me basically handing the shotgun with which the guy can shoot me if I should ever misbehave. So now this state can no longer be enforced on the blockchain, and we can make up a new state. We create 2 new secrets. We create an updated version of the transaction, again with the fallback position that if any one of us misbehaves, then the other one gets both his own and the other guy's funds. And then we can go along and update. Okay. Yeah, so this is the the hardest slide in this whole talk. So if you survive this long, that's good.
The secret is just a private key, so you can validate that you got the actual secret.
So there's a few ways of implementing the secret. The secret could be either a private key. So if I reveal my private key to the other party, then they can also sign. Or what we use in Lightning is a hash. So I basically say, hey, if you can provide me with the secret that matches this hash, you can grab these funds, because that means that I misbehaved. And if you cannot, then I didn't tell you the secret, so I didn't misbehave yet.
So that secret leads to the hash?
Yes. So the hash is basically just the hash of the secret.
Right.
And if I misbehave, I give him the secret?
So what you do is basically, okay, we have a channel set up, right? We agreed upon a certain state. Now, I promise you not to use the old state. And if I were to use the old state, then you would have the secret, because that's part of my promise, right? It's like, let's agree on an update, and here's the shotgun with which you can shoot me if I ever try to misbehave with that one. So I actually give you the tools to punish me. Because we want to make forward progress, not...
I'm trying to follow the explanation, and one thing that I see missing, that I see how it could be not understood, is you're giving the shotgun, but I would say that you're giving a shotgun without bullets. And then if you misbehave, the bullet automatically gets given. And then he can
sort of, yes. That's actually a good explanation, yes. So we need the shotgun and the bullets. That's a good way of explaining it, yeah.
Could you point out the bullets? How they automatically?
So the bullets are these. Me as the green node, I'm not supposed to know the blue secret unless blue gave it to me.
That's fine, but how does he get them if he misbehaves? Yeah.
So it's basically, we have a state. Now we want to create this new state, okay? And for us to, so we create the new state, and now that we have the new state, we basically say, okay, if I ever use that one, shoot me. And shoot me by revealing the secret.
Why should I reveal the secret if I misbehave?
Well, you did before. So we agree on the old state. Now both states are valid, right? We can't make any forward progress because, well, there's still this old appendix we'd like to get rid of. Now we make sure that this appendix cannot be used anymore by basically making it really toxic. If we ever try to use it, we die. Yeah?
So with cryptography, you kind of ensure that the other party can say, we agreed upon something.
Yes. So exchanging the secret is us agreeing on this no longer being useful.
So how are you preventing the other party from misusing the shotgun?
Because the shotgun is special for this transaction.
No, because your signature, he has that. You gave him his signature. So you agreed upon something, and you can also show that he agreed upon something. That's the shotgun you give to each other. And the bullet automatically fires because you automatically get the opportunity to fire the bullet if the other one misbehaves, because then he signs the contract like he did not sign the other one.
Okay, I see I need to improve the slide. Sorry about that one. Yes, so the shotgun is state specific. If an old state should ever show up, then we can run into the armory, pull out the shotgun that we were supposed to use for that state, and kill the opponent by taking his money.
Yeah. Excuse me, so you can
here, and then so basically then for the new state, then you have all the secrets we needed.
Yes, exactly, yes. Every time we make a forward step, we create a new set of secrets so that when we make the next step, we can actually use them, reveal them, and make the state invalid.
We need to go to the next slide. It makes more sense if we go to the next slide.
This
Yeah, so I think this question was already asked, but I just want to ask for some clarification. So I think I understand you just basically validate the transaction of giving all your funds to the other party.
Yes, yes, yes. You give the ability for the other party to steal your funds if you ever...
Makes great sense. But yes. So the question was, how do you prevent the other party that you validate your transaction for then screw you over? So you get a shotgun, how do you prevent that party from just shooting you and walking away with your...
Well, because for...
Because then you can do the same to them?
No. Because for the shotgun to be useful, it needs to be my misbehaving transaction and not theirs. I lost someone. 5 more minutes. Okay, cool. So shall we do this quickly? So the one thing that was pointed out before is that having a channel only to one party is quite useless. So what we do is we actually create this multi-hop payment system with a technology called HTLCs, which basically mean that I can send money to one person, that person forwards it, and that person forwards it to the next one, until I actually reach my intended recipient. And with this, we create a network of payment channels with which we can connect any two parties in the world. Think of if you visit Facebook, you're not drawing a copper wire from your computer to a Facebook server. You're connecting to your ISP. The ISP will forward the packets to the next ISP, and so on and so forth, until you eventually reach Facebook. So there is no need for this direct connection anymore. And the way we do this is a technology called HTLCs, which I'll probably skip because it's quite hard. So what I do is basically I promise to you a certain amount of money, or I get my money back after a timeout. You will get the money if you can show me a secret matching my puzzle. So basically, I challenge you to provide me with a secret that matches my hash in order to get the money. So the first hop might not have it, but I give him a hint where to look for it. So he will go on, forward this HTLC to the next person until we eventually reach the intended recipient, and the intended recipient has the secret, enabling him to pull the funds from the last channel. At the same time, giving the second to last hop the ability to pull funds from its predecessor, and so on and so forth, until it eventually reaches me, revealing the secret to me, and the funds eventually end up at the destination. So we were talking before about privacy. We have implemented onion routing on top of this, meaning that that any endpoint that any node in the network does not know where a transfer that it forwards comes from or where it goes. All we know is, hey, me being the middle guy, I got a payment from left, and I'm supposed to forward it to right, but that's all I know. I do not know, is this the original sender, or is this on behalf of somebody else, and I don't know where this is going to, or whether this is already the final destination. Okay, so advantages.
How do you navigate them?
We do know the entire topology of the network. So, well, you basically have a header which explains for every hop who is going to be the next hop in the network. And it's encrypted in such a way that you only see your own data and where it should go next. It's basically just a packet header that tells you where to route through. Okay. So advantages. Well, we set out to solve scalability. We definitely made some huge progress. We can actually do thousands of transfers per second on channels. We can have millions of channels. So I think that scales pretty well. We actually have real-time transfers. We no longer need to wait for a block confirmation in order for this payment to be final. As soon as the payment reaches the barista, he can be sure there's no way for me to get my money back, because he always has the ability to enforce our last agreement on the blockchain. It's basically we discuss off-chain, and if anybody goes away or we have an argument, we just go to the blockchain as a court that settles this issue once and for all, and they will have proof what was the last thing that we agreed upon. We have improved privacy. No longer will all of our transactions end up on the blockchain. No longer will we be able to create profiles. I did some studies with students myself, trying to cluster addresses, and it's quite easy. We have onion routing on top of that, which means that that even intermediaries can't see where a payment comes from or where it goes. And this actually allows us to have fast experimentation. This is not on the Bitcoin blockchain. This is a protocol built on top of the Bitcoin blockchain, meaning that all of the stuff that we discuss are not consensus critical. All we need to do is have the ability to express our agreements in something that the blockchain can do. How we communicate, none of the blockchain doesn't care. Okay, so the community, this is not a Blockstream project. This is actually a project by Blockstream Eclair Lightning Labs, MIT DCI, and Bitfury. We are collaborating in the open on a protocol specification. This is close to be done. I don't have a definite answer on when it will be public, but should be close. Yeah. So coming from a research background, this is the most interesting part for me, open questions. So we have the routing problem. Currently, everybody has to know the entire topology of the network. Everybody has to know exactly who is linked with whom in order to make this onion packet, so that we kind of say, okay, once this packet reaches here, then the next hop will be here, and then so on and so forth. There's alternatives that we could use, but for now we just went for onion routing, which is secure by default, and we can open this up later again. Network topology, huge discussion. We don't know whether it's going to be hub and spoke, whether it's going to be a mesh network, whether it's going to be a planar graph, whether it's going power law graph. But we can argue about this, and hopefully we will see this soon, how it actually evolves and how this network is built. SegWit activation, that's done. And payment decoupling, we currently use for the HTLCs, we always use the same secret. So if I'm multiple times in the route, I can actually correlate payments. So if I got a payment here and I later see the same secret again here, then I know that this is probably from the same payment. Okay, so that's it, and I hope you have loads of questions. I'm sure you have.
How long will it take before Lightning can create a seamless user experience that's able to rival the experience of how Bitcoin used to function before the network became congested, while also competing with alternative cryptocurrencies that do not have these arbitrary restrictions today? Specifically, how long will it take before Lightning Network will always find a route with all peers accepting Bitcoin Lightning without ever touching on-chain from the perspective of the users? Seamless in this context means that there should be no extra steps or considerations for the users. This user experience can be compared to a Bitcoin Cash to Bitcoin Cash transactions and how that practically functions today, or how Bitcoin used to function before the network became congested.
Okay, so
There was one question.
you have rehearsed that, haven't you? Okay, so first of all, most of the other networks that currently claim to scale can as well. They don't have the same load that Bitcoin. For the user experience part, I'm pretty hopeful that we will have this user experience soon. I'm not a user UX or UI person myself, so I can't really say much about that. But there are ways to make this as seamless as possible. Having classical Bitcoin payments out of Lightning channels, so you only show one balance, have these channels established in the background, have the routes optimized in the background. So all you would see is basically your current balance in Bitcoin and the transfer history that you did. That should be the entire user experience, and we know how to get there. It just takes a bit of time to preempt that question. I wanted to say we are pretty close to finalizing the specification. We are integration testing all of the 3 spec-compliant implementations. You can actually test this now on testnet and testnet, rectest, and Litecoin. I shouldn't say this, but you can test it on mainnet. Just don't put too much money on it. This is untested software, so beware there be dragons.
The question is, could you give us a ballpark on the timeline before people could get a user experience that equals old Bitcoin or its current competitors?
Ballpark figure, 6 to 9 months.
Thank you.
Okay, thanks Christian. It's a really interesting session now with a lot of questions. I'm still trying to get my head around the green and the blue stuff. But thanks again for explaining the Lightning Network.
Oh, I can explain more later.